All right, let's do a quick review of all the types of data that we have used in questions, because it can be pretty overwhelming to have so many things concerning rate. So take a look at this first table. You have trials 1, 2, 3, and 4, where the concentrations were measured and the rate was measured, and technically it's the initial rate. And that is when we use the method of initial rates to find the orders of reaction to write a rate law. So typically, this question you're solving for orders, a rate law, and also you could be asked the value of K. All right. If you have this kind of data, this is our basic data for kinetics. You have a reaction, you measure the change in concentration over time. So previously we have done instantaneous rate with slope of the tangent line. So you just graph it straight up, concentration versus time, and then draw the tangent line at a certain time to determine the rate at that particular time. Then we have determined the order by graphical analysis. So we make all 3 graphs that correspond to the 3 integrated rate laws and see which one is the best fit. So here was our integrated rate laws, and we can determine the order. So if you're given this kind of data and asked the order, then you need to do these graphs and see which one is the best straight line. You could also be given this order, this data, and asked to determine the order, and that relates to method of initial rates. Then we also have where you're given just word problems, and you can use the integrated rate equations depending on what order is stated in the problem. If it behaves first order, you'd use the first order equation. If it behaves second order, you'd use the second order equation, and so forth. And then our last type of data problem is when you have temperature, when you change the temperature and measure the rate or the rate constant of the reaction. So then you can use one form of the Arrhenius equation and graph it, and you can determine the energy of activation from the slope. Or you could be given a word problem, and where you have the sets of data for K1 and T1 and K2 and T2, and use the other form of the Arrhenius equation, the natural log of K1 over K2 equal to the energy of activation over R times 1 over T2 minus 1 over T1. And so that's a summary of a lot of the different types of problems we have in this unit and how to put them in perspective.